to my channel. Today I am starting rational numbers. The concepts and ideas of 8th standard mathematics would be explained to you in a very simple language so that you will love to learn mathematics. Okay children, let us start our first chapter, rational numbers. Last year you have come across proper fractions and improper fractions, isn't it? The collection of proper fractions and improper fractions are nothing but rational numbers. Do you understand? Let me give you some examples. You know 3 by 8 is a proper fraction. Let us write the reverse of it. 8 by 3. This is a improper fraction, isn't it? Now, this proper fraction and this improper fractions are commonly called by a name rational number. Do you understand? When we say whole numbers, we mean 0, 1, 2, 3, etc. Okay, we can call these whole numbers to be rational numbers. Why do we call whole numbers as rational numbers? Because 0 can be written as a fraction. If you want to write 0 as a fraction, you can write it as 0 by 1. Isn't it? So, 0 by 1 is a fraction, or you can call it as a rational number. Similarly, all counting numbers, that is starting from here, 1, 2, 3, etc. can be called as rational number. Why do you call them as rational number? Because they can be expressed in the form P by Q. 1 can be written as 1 by 1. 2 can be written as 2 by 1, etc. Is it clear? Now come to the left side of this. If you come to the left side of 0, you know you have all negative numbers arranged on this side. -1, -2, etc. up to infinity. 1, 2, 3, etc. up to infinity. Okay. Now, these negative numbers can be also called as rational numbers. Why? Because -1 can be written as -1 by 1. -2 can be written as -2 by 1. Is it clear? So, you got an idea about rational numbers now. So, what are rational numbers? Any number which can be written in the form P by Q, where Q not equal to 0 is a rational number. Is it clear? So, you can call 0 to be a rational number because it can be written in the form P by Q. You can call any positive integer as a rational number because it can be written as any number by 1. Clear? Similarly, you can call all negative integers to be rational numbers. It is because a negative number can be written as a fraction. Hope the idea is clear. Often children have a difficulty to identify rational numbers. So children, rational numbers are nothing but numbers of the form P by Q, where Q not equal to 0. Can we call 1 by 0 a rational number? No. 1 by 0 cannot be called as a rational number. Do you understand? Because 1 by 0 is not defined. Okay. 1 by 0 is not defined. Whereas 0 by 1 can be called as a rational number. It is because denominator is not equal to 0. Children, let us discuss the properties. First of all, closure with respect to whole numbers. The 4 operations I have listed one by one: addition, subtraction, multiplication and division. Here under addition, you take any 2 whole numbers. Okay. For example, you know 0 is a whole number. Let us consider 2. 2 is another whole number. Let us add the 2 numbers. 0 plus 2 is equal to 2. by adding two whole numbers, you get another whole number. So we say whole numbers are closed-ended addition. For any two numbers A and B, A plus B is closed. So we say whole numbers are closed-ended addition. Come to the second property, subtraction. Again take two whole numbers. Let us take the number 2. Let us consider another number as 5. Let us subtract 2 minus 5. What do you get here? From a smaller number, you are subtracting a larger number. So you are going to get a negative number. Can you say it is closed? No, it is not closed under subtraction. From this, what can you say? Whole numbers are not closed under subtraction. Third property, multiplication. Take any two numbers. Let us take that same two numbers 2 and 5. 2 into 5 gives you 10. 2 is a whole number, 5 is a whole number, 10 is also a whole number. So we can say they are closed under multiplication also. What about division now? Take a whole number. Let us take for example 2. Let us divide it by another whole number. Let us divide it by 5 itself. Okay, 2 divided by 5. What do you get? You get a fraction. Can you call a fraction to be a whole number? No. So we can say division is not closed in the case of whole numbers. Children, let us have a quick look at the closure property of integers. When we say integers, we mean negative numbers. We mean negative numbers, 0 and all positive numbers. Just look at addition, subtraction, multiplication and division. What about addition? If you add any two integers, you get again an integer, isn't it? Take for example minus 2 added to 0. What do you get? You get minus 2. Minus 2 is also an integer. So for any two integers A and B, A plus B is also an integer. So we can say integers are closed under addition. What about subtraction? Take for example 5, which is an integer. Let us subtract 2 from it. 5 minus 2, which is equal to 3. It is again an integer. So we can say it is closed under subtraction. Come to multiplication. Take any two integers. Let me take a positive integer and a negative integer. Minus 5 into 2 gives you minus 10, which is again an integer. So we can say it is closed under multiplication also. What about division? Take for example a negative number. Let us divide it by another negative number. We are dividing negative 5 divided by negative 3. You get 5 by 3, which is a fraction. Sometimes you may get a integer itself. Okay, here we say they are not closed under division. Children, let us see the closure property in the case of rational numbers also. Again, let us discuss addition, subtraction, multiplication and division. Let us take two like fractions. Okay, so addition of two rational numbers. I am going to take like fractions so that you will understand very easily. I am going to take 1 by 7 and 2 by 7. 1 by 7 plus 2 by 7. What is the answer? You get 3 by 7. Since the denominators are the same, you wrote the same denominator. 1 plus 2 gives you 3. For any two rational numbers A and B, A plus B is also a rational number. So what can you say about the remark? Here you can say they are closed under addition. Let us come to subtraction. Let us subtract two like fractions. Let me take 3 by 10, from which I am going to subtract 2 by 10. What is my answer? 1 by 10. So we can say for any two rational numbers A and B, A minus B is also a rational number, so it is closed under subtraction 2. What about multiplication? Take for example any rational number, 2 by 7. Let me multiply it by 3 by 5. You know, when you multiply the numerator with numerator, you get 6. Denominator with denominator gives you 35. So this is again a rational number. So we can say it is also closed under multiplication. Come to division. Let us take these two numbers once again. Let us divide 2 by 7 divided by 3 by 5. How do you divide, children? We multiply with the reciprocal. Division is nothing but multiplying with the reciprocal. So we write 2 by 7 into division. I have written it as multiplication. 3 by 5 reciprocal is 5 by 3. So this is equal to 2 5s are 10, 10 by 7 3s are 21. Okay, so we can say this is also closed under division excluding the number 0. Is it clear? If you exclude 0, all the other rational numbers are closed under division. Children, we have discussed closure property in the case of whole numbers, integers and rational numbers. In our next class, let us discuss the commutative property. Okay? Share your valuable suggestions in the comment box. Thank you.